So my name is Dimple. I am the sales and marketing assistant here at Cintiqa, and I'm offered to do this little interview with you, and I'm very excited to do that. So this here is Dr. DeLeon-Pennell. She was trained in cardiovascular sciences at Baylor University, University of Texas Health Science Center, San Antonio, and the University of Mississippi Medical Center. She has more than 10 years experience with all aspects of inflammatory and fibrotic components of cardiovascular remodeling following a heart attack. Her current research project her current research projects focus on the role of the adaptive immune system and how it interplays with the innate immune system to regulate cardiac wound healing. This includes evaluating how existing confounding variables such as gender or aging changes these processes. So, those are a lot of words.
Yes.
A lot of very big words. How could you describe your research that you're doing in maybe layman's terms?
Sure. So basically, what we're focusing on is how does the heart heal after you have a heart attack?
Okay.
So the heart is one of the only organs that cannot actually replicate. So your cells in the heart cannot actually make new. So the muscle cells, once they're dead, they're gone. And so what
Okay.
ends up happening is you have to form a scar. And so what we're trying to do is figure out how does this scar form? What makes a good scar? And how can we as physicians, as clinicians, what can we do to help that the patient form that good scar that we want, so that they don't eventually develop things like heart failure. And so that's what we're really trying to dissect is what immune cells, what molecules can we look at as a possible therapy.
Okay. So kind of like triggering the heart to repair itself with scar.
Correct. So it already
That's
makes a scar, but we just want to make
mhm.
sure it's a good scar.
Yeah, okay. So with that being said, what really triggered you into steering your research in this direction of like looking at what happens after a heart attack and then trying to have that heart like try to repair itself?
So, I mean, one being the cardiovascular disease is the number one killer in the United States. I
Mhm.
think everyone knows someone who has had some form of cardiovascular disease.
Yeah.
I've had my grandparents have had heart attacks. One of them actually passed a couple years ago from a heart attack. So
Mhm.
I think, all of us know that this is a big problem.
Yeah.
And so with my research wanting to really focus on something that is a large problem, I think that's kind of what steered me in that direction. It's funny though, in grad school, I hated immunology. I thought it was the worst course ever. It was really, really hard for me. But
Yeah.
here I am in immunology doing all this immune work, and I love it. I really do
Yeah.
love it. And it's kind of funny how that kind of comes back on you.
Yeah. Was there a moment, do you have like a specific moment from when you were doing your academia and while you're doing your research where that kind of your mindset changed with like not liking it to like you now it's like your life passion, I'm assuming.
I think it was really just being there at the bench and,
Okay.
kind of reading about it and learning about it and realizing, in a class it's different. You're just
Yeah.
trying to memorize the information so you do well on a test. But once you're
Mhm.
at the bench, it's a little bit different. You're trying to understand it in a different aspect. And I think that getting getting my hands in there and kind of more experience kind of made me not understand it necessarily, but um can't think of the right word.
Tip of your tongue.
Yeah. Yeah, tip of my tongue, but basically I just started liking it more.
Okay, okay. I mean, like that's good. So, with this research, what was the most challenging part? That you mentioned this transition. Was that hard for you to kind of start viewing it? Was it hard for you to go from academia to like the bench, or was that transition like pretty easy for you because you did say you enjoyed it?
So my grad school was actually in biophysical chemistry. So I
Okay.
had no animal experience, no cell work experience. It was really
Hmm.
all on peptide work and how does protein structure relate to function.
Yeah.
And so, um, it was a big jump for me to go from, a very, very basic
Mhm.
lab to
Yeah.
something that's more translational. But that is
Yeah.
what I wanted. So after
Mhm.
grad school, I purposely sought out a lab that could teach me those techniques, teach me animal techniques, teach me, and cell culture techniques. And that's when I joined the lab of Dr. Mary Lindsay, because I wanted that experience.
Mhm.
And so it was a little bit hard making such a big 180, you
Yeah.
know, um, and trying to catch up with some of my peers who had tons of experience and techniques that I had never even tried. But I think in a way it was very advantageous of me, and also because I had my mindset was different. I was being more chemistry trained. My mind worked more mechanistically. I liked
Okay.
to think of how step by step how things worked. I wanted to know, okay, X happens, then X happens, then Y happens, and so that's how I do everything now, but more in a
Mhm.
biological way instead of a chemical way. And so, in a way, I think having that training really has helped me transition, even
Mhm.
though it was a little bit hard at first. But it
Mhm.
did help me because my mind has been able to uh, think in a different way that maybe it wouldn't have if I had a more of a biological training.
Yeah. You're able to adapt and overcome and adjust.
Yes, of course.
So you mentioned your mentor, Mary Lindsay, Dr. Mary Lindsay, and when I was offered like this chance to get to talk to you and get to know more about like your background, she was mentioned, and a lot of people had very, very nice things to say about her. How is it working under her? I heard that she was there at the very beginning of the Doppler flow velocity system, like the creation of it. How is that? What was your experience of being under such a person in science that has been a part of a lot of defining innovations in preclinical
Um, I
research?
I mean, it would. I cannot say anything bad about Mary. I have loved every minute that I was in her lab. I learned so much from Mary. I mean, she gave me a chance. I mean, not many people
Mhm.
would take someone with a chemistry background and put them in a biology lab. She
Yeah.
gave me an opportunity to learn something that I had never learned before, and she's a wonderful mentor. I was able to learn a ton in my time in her lab, and it was wonderful to kind of be able to not only watch but experience everything from the ground up. And I
Mhm.
think in a way it's kind of i I've learned a lot. My mentoring style is a lot because I mirror it after her, and that's how I've kind of formatted my own lab, is
Yeah.
from what I've learned from being in her lab.
Okay, awesome, that's great. And then I also wanted to ask, like, with this, transition of, like, not really knowing too much going from biology to chemistry, what was, like, the most surprising, like, scientific finding that you had in your research?
um that's a good question.
It's kind of like a loaded question, I know.
I mean, I think every day there's always something that I'm like, "Oh my gosh, I never would have even
Yeah,
considered that."
yeah.
Actually, we just had a paper that was just accepted in AJP Heart,
Oh,
and
wow,
we
congrats.
thank you. And so the reviewers wanted us to add a control to our experiments, and all it
Yeah,
was just add a control antibody. We didn't think it would do anything,
yeah.
right? Well, it did something, and we
Okay.
were like scrambling, like, "Oh, okay, now why would that happen? It's just a
Write it all
control
down.
antibody, right?" So we repeated it multiple times, like, "Okay, why is this happening? Make sure
Mhm,
it's not, make sure it's not that we did the experiment wrong. Make sure it's not this. Make sure it's not that." And it was true. And then so we look in the literature and we're trying to figure out, okay, why would this have happened? And then we came up with this, based on what we read in the literature and based on what our data is telling us, with this new data, this new whole hypothesis that we hadn't even considered, you
mhm.
know. And I think that's what science is so wonderful about science, is that,
Yeah,
sometimes things don't work the way you think they're going to work, but it's a good thing. It's a blessing in disguise,
yeah,
because now you have this new idea that you never had even considered.
mhm.
And now it's something, a new idea that you may actually find a new discovery that no one even, thought about until your happy
Yeah,
accident.
yeah. No, it's funny that you just like went into like that whole story because my next question was, what is the coolest thing about your work slash research? Like, I feel like you kind of answered it in that question because science, like, it's so unpredictable. It's so like structured, but in its essence, but completely unpredictable. And I think like it's amazing how like you can find like most discoveries, like insane discoveries, are found by just something like that just happened, where you just like
Hmm.
randomly put in a variable and see what happens, and then a lot of stuff actually happens.
Yeah, exactly. Yeah, I mean, I have two young kids, and people make fun of me because my kids know things that they really shouldn't, because we
Yeah.
talk about science and hypothesis driven science all the time.
Yeah.
But I tell them all the time, I was like, the data is where you follow.
Hmm.
It's the data. You have your own hypothesis and everything else, but if the data doesn't fit your hypothesis, then that doesn't matter. It's the
Hmm.
data is what you follow. That's going to be
Hmm.
the truth. And so
Yeah.
that's what we always have to do, is pay attention to that data, because it may surprise you one day, and then you're
Yeah.
like, oh my gosh, this is not at all what I thought would happen, but
Yeah.
it's the most interesting part.
Yeah. So with that, do you have any particular challenges that you face in your lab?
I mean, I think being a new investigator, there's always new challenges, because
Mhm.
we're learning still.
Yeah.
Managing people was a challenge. It still is a challenge. We're still
Mhm.
learning on how to manage people, how to ensure that everyone is getting what they need.
Mhm.
Because I think a good mentor, good PI is not only worried about what they need, but what everyone else needs, so that they
Yeah.
can, as a team, be successful. And so I think that that's something that I've had to learn over the last 3 years,
Yeah.
is how to ensure that everyone is getting everything that they need, so that we can all be successful.
Mhm.
Um, and so I think that's kind of been the biggest challenge for me, is just ensuring that I'm paying attention and
Mhm.
listening,
Yeah.
and not getting too caught up in my grant writing, or whatever, that's
Yeah.
going on,
Yeah.
and being a good leader.
Yeah. And on that note, do you have any advice that you would give to younger people who are interested in this similar career field?
Sure. I have lots of advice.
Go for it.
I think the biggest advice that I've taken to heart since, high school, probably, was,
Mhm.
fail your way to success. Failure is not a bad thing. Failure is a good thing, in fact,
Mhm.
because every time you fail, it should be a learning experience, and every failure is just a way for you to learn. And so, I've really taken that one and really made it kind of my motto, if you will,
Mhm.
because every time something doesn't work, it's not some doesn't mean like we throw our hands up in the air and quit. It
Yeah.
means that we just regroup, rethink, and we learn from it. Okay, that
Yeah.
didn't work. Okay, now how can we make it work? If
Yeah.
that didn't work, then now we have another path that we need to
Yeah.
go. And so that is probably the biggest advice I have, is don't be afraid of failure, because it's just a learning experience.
Mhm.
And don't be afraid to follow the path that people don't usually follow.
Mhm.
I mean, I didn't get to where I am by following the path that everyone else followed. I made my own path. I went
Yeah.
from chemistry to biology for, so
Yeah.
I made my own path, and don't be afraid to do that. Don't think that you have to do something in order to be successful. Don't think that you have to get some, a fellowship, or whatever. Make your own path, make sure it's what you actually want, because that's the only way you're going to be successful, is to make sure that it's what you want, and not what everybody else is telling you that you want.
Mhm. Wow. As a young person, that really touched my heart. Thank you so much. That is like what I need to hear after this whole year of just like crazy pandemic and all that. So in I this wasn't a question that we had pre-selected or anything. It's just something that I wanted to ask just because we were talking about. How is doing your lab and starting your lab up during like this whole year of complete chaos?
I mean, it's been crazy, for sure. I
Yeah.
mean, like I mentioned already, I have two young children, so,
Mhm.
with schools closing and everything else, I had to find a way to be mama and be PI, which
Mhm.
is probably the most difficult thing I had to do, because that was not easy, for sure.
Yeah.
But I think that the thing that any hardship like this teaches you is that you are strong, you're resilient, and that we can do it. And I think that
Mhm.
that's, and, I think having kids taught me that alone, just having the
Mhm.
kids, and
Mhm.
now we're in kids with a pandemic, and now I'm having to relearn some things and
Yeah.
reassess some things and prioritize some things. But I think every single hardship that I've ever faced is just another way of becoming stronger,
Mhm.
becoming more resilient and learning what my priorities are.
Mhm.
And so, yeah, it's been hard, but I don't like to think of the bad stuff. Like to think of
Yeah.
it as a way of learning, of growing.
Yeah. Yeah. I love that. I love that so much. So, on that note, do you have any future research directions? Like, what is coming next after your research with heart and heart attack? Are you gonna do you, like, obviously you talked about how you have a history with people in your family having heart diseases and stuff, and are you going to expand on that, and that's going to be like what you're going to be doing for a little bit, or do you have any other interests within your research that you've been like thinking about?
So, we're sticking with the heart for sure. But
Yeah.
one thing that I am interested in is looking more at how things like your sex, your gender, and
Mhm.
your age, right?
Mhm.
How that is a big confounding factor of
Yeah.
cardiovascular disease. We
Yeah.
know that women don't have cardiovascular disease until later in life, right? We don't
Mhm.
really quite understand why, whether it's hormonal, whether it's chromosomal, whether it's, just, the way we are, just are,
Mhm.
so we're really interested in that component of what is happening, what is the drivers, and how can we basically make a more personalized medicine for women versus men, or
Mhm.
can we make a blanket treatment that will affect both men and women evenly,
Yeah.
which I think is obviously the best goal, is
Yeah.
that we have a treatment that can treat everyone. But I think
Mhm.
that's a little optimistic, honestly.
Yeah. Yeah.
So I mean, that's one of the big goals for us over the next couple years, is really dissecting out the sex differences and the effective
Mhm.
age, and how is that affecting our immune system and affecting our ability to heal after a heart attack.
Yeah, yeah, that seems like very important stuff that the world needs to kind of develop, and that's amazing. So I've reached like my end of my questions. So I just wanted to thank you for giving us some time today for having this interview. Your research, thank you for explaining it a bit more in layman's terms that I can like kind of understand. And yeah, I really appreciate you taking like time out of your day to do this little interview with us. And hopefully we'll have this back to you and everything when we have it all primed and propped and everything.
Well, thank you
But
for having me.
yes, of course, thank you. And very inspirational, just by the way.
Thank you.